Okay, so I've got this empty workspace with nothing in it. What I'm going to do is I'm going to go back to the web page. I'm going to find the source code link for that Git stuff. I'm going to go grab whatever it says for a URL that looks reasonable. Mine's going to be a little different than yours because I have commit permissions. And I'm going to go and do a file, import, Git, projects from Git, click next. Sometimes you'll see a URI in here, sometimes you'll see clone. It depends on permissions again. And all I'm going to do is when I see that dialog box, I'm going to paste in all of that URL information. It reformats the whole line into where it needs to go in the dialog box, except you have to backspace to get rid of that one little extra space that's there that it didn't take care of. Click next. Say yes, master is fine, for whatever that does. And now here's the name conflict. It says, oh gee, you've already got something in your Git folder called Comp132. Okay, so I don't really care about that Comp132 folder, so I'm just going to go to my file browser, find my Git folder, because it's just a local copy, delete the Comp132 folder that's causing the name conflict, and try again. Click next. This time it's happy. It says, oh, no more name conflict. The local copy is gone. You can click next, or you can just click finish here. And there's the repository. It found it. Import existing projects. There's the list of all the projects that I've posted so far. And now I've got all of the code back again for what we've done so far. Okay, didn't take long. Pretty much guaranteed to always work. Didn't have to worry about update problems. Got to be the latest that Pfeiffer's posted. Okay. The one we were working on was the donation beast. And so we've got donation box. And now we're going to ignore the driver. And yesterday we worked on this idea of unit tests. And we said that for a unit test, what we've basically got is 3 different little mini main programs. Okay? And each one of those little mini main programs is a separate test to see whether or not something within that donation box class actually works correctly. So the first test says, let's make a new donation box. It should be labeled Salvation Army. And just to make sure that it's been created properly, we go and we ask it, what's the name on the front of the box? How much money do you have in you? And then we double check to make sure that the amount of money that it said is in the box should be 0, and that the name that it said was on the front of the box should be Salvation Army. Okay? That test is specifically designed to see whether or not the code that we have for that constructor works properly. And the code for that constructor that new calls is this one right here. And the responsibility of constructors is to take information in and copy that information onto the form when it's first made. So only when it's first made. And this is an interesting thing about constructors, is that quite often here you'll see there's 2 pieces of information that we need to initialize. In this case, one of the pieces of information came from the outside world. I need you to put this label on the front of the box. And the other piece of information, the how much money, we just said, we don't care what they say on the outside world. We're going to make sure that every single box we make has this amount of money in it. And so that's fairly typical. You get some pieces of information coming from the outside world that you have to initialize, copy those values, and other values you just set to what you think is going to be appropriate. Okay. We did a second test to make sure that when we put some amount of donation into the box that it was correct. So we made a brand new fresh box for this test. We gave it the same name as the other one, but since it acts like a mini main program, it's like starting up fresh again. We donated some amount of money, and then we turned around immediately and said, hey, how much money you got in the box? And the answer should be the 100 pennies that we put in. Okay? And that little pattern is really, really typical in any of these unit tests. You know what the initial state of the thing is, you kick it and ask it to do something, and then you immediately go and check to make sure it did what you said it did. So there's always this double check.
I was just wondering, since we did a value for the money inbox equals to 100, and we typed that in as 100,
Yeah.
is there another way to actually check the Sally.donate to see what that number is instead of having us to type in what the actual number is? You know what I mean?
No. So, you know, the donation box is holding on to all the information. And it's an individual where you have to ask it to do things, and you have to turn around and ask it to tell you what state it's in. Ask it to supply information back. And so it's in control of the stuff, and so you're just turning around and asking it to do things. If the question is, can I somehow have me as a user type 100 and have it inquire and ask? The problem with using user input for testing is that the user can change their input and you have no idea what it is. And so what we're trying to do here is we're trying to customize the testing so that we know exactly what it is. Okay, so that's why there's never going to be any user input in these things. Okay, so there's the second test, and that test is, can it accept one donation and record some amount? What's the reason for the next test?
Check adding them together.
Check to see whether it's adding them together. What it could be doing is there could be a hole in the box, or it could be just keeping on to one, and whenever you donated more, it for some reason decides to throw away what it's got and just put the new value in. And so we want to see whether or not it's totaling the stuff to get the correct answer. Do you remember why we put in this, why we didn't make these two the same? I think we had an original test that looked like this. Why is that test not so good compared to what I just had? They look about the same. I just added some number.
Because they're the same values that you're adding?
If they're the same values, why does that make a difference? If you go back and look at donation box, let me mess up donation box in some bad way by saying, oh, every time you give me more money, I think you're giving me $1, 100 pennies. Okay? So there's an idea of something that's obviously broken, because you can see it's ignoring the value of more money and just arbitrarily setting it to some value.
Also, there's no pass test.
Well, now the question is, I mean, we've got this test, and if we're checking to see whether or not it adds correctly, this thing should fail. You know, if the test is written properly and we're checking to see is it adding, it should fail for all cases. And what happens when you run it is this test succeeds. So there's the second donation test succeeding. Okay? The reason it succeeds is because for somehow magically in my unit test I chose to add 100, or in the code I chose to add 100 every time. You happen to pick values in the testing that was adding 100 every time, and so we're always going to agree no matter how many hundreds you add, it's going to look like it's valid. So the only way that you discover whether or not they're appropriately adding is to change the game up a little bit and add some different amount the second time, and now you'll catch them in the act. Okay? So there I went and I actually messed up the code that I had, which I thought was working, in order to see whether or not the unit test was correct. And now I'll hold it here with a better unit test. Now I know that I've got a test that makes it fail. So this test is correct, the code is wrong, and so we'll go back to the code and we'll change it to what it was before, to more money. Okay? Now, here's another thing I could have done. At some point, suppose we write something to do 3 donations. I'll just stuff one in here to do 3 donations. The name is a little bit wrong on the test, and I'll put in 300. Okay? Actually, let me just, yeah, okay. I'll put in 300, and I'll change this thing to, what's that going to be, 600 on a good day? Here's another little testing trick. that thing is already getting difficult to read. So there's a couple of things you might want to do. The first thing that you might want to do is say, well, I'll just put a loop in there, and I'll start a loop. I equals 100. I is plus 100 every time for 3 times to do that same thing. What do you think about putting a loop in there?
It's hard to read.
It's hard to read. It's hard for your, if we do the mum test here, it's hard for your mom to have to explain to your mom what a loop does. It's easy to explain, hey mom, look, I added 100, then I added a 200, then I added a 300, and the total should be 600. Okay, so there's this idea that unit tests should be simple, clear, obvious, probably not do a lot of loops, be very, very small. One of the reasons why you want to do that is because you want to make sure that when you look at the unit test is 100% correct and easy to understand, and that tells you the problem is in your source code. If you start making really complicated unit tests, then when it fails, you go, well, is that because the test is too weird, or is that because it's the code that's broken? Okay, so we're trying to limit where we have to look for the changes. Okay, now I talked about not having loops. Let's also talk about using patterns for a second. Okay, let me make one little change to this code that's going to make it a little bit more obvious what's going on. In the unit test, just to clear things up, notice what happened there. Okay, in the first version that we just saw, I had to look at the test and I had to go, where'd that 600 come from? Let's see, the 600, oh, go back up and look at the unit test. Oh, okay, 600 is 100 plus 200 plus 300. Got it. And so the test was forcing me to do some amount of math and brain work, which I'm not really good at, in order to see what the result was. And here's just a simple fix to the thing of putting in that change so that I don't sum things up for them and I let people see the actual individual ones, and now all of a sudden it's a lot easier to understand. Okay? Just a simple trick makes our life really, really easy. I'm still going to put this one back down to take out that value and take out that value to get it to be the kind of test that it was supposed to be to begin with. But even then it's more obvious. Oh, look, it's just 100 plus 200. If I wanted to make it even a little bit more obvious, even though technically speaking I don't have to check this other donation, I'll just convert this code here for a second. Get rid of reuse that variable, so get rid of that and make the test look like this for a second. Let's clean it up a little bit, put some paragraphs in here. And this just becomes the 100. Okay, so there, even though I didn't have to check to see whether the first one was correct, because I know from the previous test, it actually makes this test easier to read, to see it, because then you start to see a pattern in the code. Oh, look, there's a donate 100, there's a donate a 200. This thing goes from 100 here to 100 plus 200 here, right? The more you expand that, if I add another one in, the pattern for the code becomes even easier to see. And so my rule here is that human beings are really bad at recognizing loops and trying to decipher them in their heads, but they're really good at standing back and looking at patterns and going, oh yeah, okay, that makes sense. I can see the pattern that's forming there. I guess it just must be right. It'd be a lot easier to spot errors in your unit tests if you do things that make obvious patterns than if you do loops. Okay, so there's another sample pattern.
So you only need to declare it as an integer once?
I reuse that variable, right? And so since I reuse the variable, yeah, I don't need to redeclare it again. As a matter of fact, it won't let you. Okay, let's take one more step here. In the donation box, as we've currently written it, people can donate negative amounts of money, which is generally a bad thing. That means they're somehow removing money from the donation box rather than putting stuff in. Okay? And the other thing is, around Christmas time, it seems that people want to give much more than they have, and we don't want people coming along and giving hordes and hordes of money and trying to stuff it in the box. We should maybe try to limit the upper end of how much they'll give just to be nice people. Okay? So let's just suppose, for practical reasons, we decide that when people put money in the box, we want to make sure that it's greater than 0, and we also want to make sure that nobody puts in more than, we'll do something small, $5, just for the pure fun of it. Can always go change it later. So we want to range from 0 to 5. So how would you make it so that we don't allow people to put money in there that's too little or too much? An if statement where, in what piece of code? Donate is the only place where they're stuffing money into the box. So there's where we want to put the if statement. What do you want the if statement to look like?
If less than 0.
If more money is equals doesn't matter, so we'll just use less than. Is less than 0 or more money. If it's, well, actually we'll do it the other way around. If it's greater than 0, I think this is what you want. Let's see if I can get it right. If I hit the right key. Greater than 0, and it's more money is less than whatever 500, then we'll say that's a suitable donation. And we'll do that. I think I got that right. If I spell more money correctly.
Do the words and more not work?
Nope. It's got to be that.
Is there, you have to put an else in there then?
Nope. Else just does nothing. Which is what we want.
Right, so it won't accept anything.
It'll only accept money that's between those ranges. Okay? Now, if that's the code, what do you want for a unit test? Start out with @test to make a new test. What do you want to check first? What idea?
The negative?
The negative. Negative is ignored. To test to see whether or not negative is ignored, oops. I'm going to basically steal a bunch of this code. I can steal all of that stuff to rewrite my new test and then morph it a bit. So I'll still make a Salvation Army box. In this case, I'll donate something like negative amount. Actually, let's donate 100 first, just so that there's something in the box. Then we'll donate, try to take 50 cents out. And then we'll check and see how much money do you expect to be in the box?
100.
Still 100. Okay, so there's the, I put 100 in, I tried to take 50 out, and it should still be at 100. And that's how you would explain it to mom, right? Pretty obvious what the test is. While we're at it, why don't we do this same sort of thing just to show you how easy it is to write tests for the too much. Almost the same test. Donate, in this case, probably doesn't matter what's in the box. Donate something more than 500. We'll donate a really big number, okay, because we're feeling it's really Christmas time. So if you donate that much, how much should be in the box? Still should be, in this case, it started out as empty, so it should still be empty.
Oh, it won't even take any of it?
It won't take any of it. It's like, no, that's too much. I can't accept that.
Say
You could make it take some, but this is just a simple thing.
500.
You know, you can make it do whatever you want, but this is the way that we want. This is my expectation, right? So one of the things the unit test does is it says, this is my expectation for what should happen when people try to donate too much money. And these are the rules I want you to enforce. And then we make sure that the code inside the class says exactly that to enforce the rules. And then we'll turn around and run it, and we'll see if the tests pass. And you can crack it open to see the full list of tests and the names. And so now that we know it works for those cases. Okay, so now let's talk about this particular style of if statement. Okay? And I'm going to give you a real life example of this if statement. Suppose that somebody comes into the classroom and they want to sign up for 132, right? They're running a little late. They walk up to the door, they open, and they say, hey, can I come in and be a part of 132? Have you read the calendar description for Comp132? For the prerequisites? It says something like, if you're in the CST program and you've successfully passed this with a grade of something more than this and this and this and this, then you can come into Comp132. Okay? So the student walks in, knock, knock, can I come into 132? I look at them and I say, okay, if you're in the CST program and you've got Comp whatever it is, the previous version, the prerequisite you needed, you got more than a C in that, then you can come in. What's the student gonna do? Not to pick on students, but normally they look at me and go, what'd you just say? And I say, oh, well, okay, if you are in the CST program, and if you've done this, and if you haven't done that, and you've got a mark more than this, you can come in. Could you say that again? Okay, is there an easier way for me to do that?
Say no.
Just say no. But if I say no, I'm saying no to the whole thing, and they don't have a sense of what of those various things was the reason why I said you can't come in.
So just ask the one at a time.
Ah, there you go. So the better way to do it is when the student comes and says, can I come in? I say, are you in the CST program? They say no. I say, get out. Real easy, right? You know, did you get a C in the prerequisite class? If they say no, I say, get out. I'm not interested, and slam the door. And so that means that now they can go through and they know exactly what the reason was why they didn't get in, and it's way less complicated for them. They only have to answer one question at a time. Okay? Well, what you're doing with this style of coding is the first let's make it more complicated thing. And that style of coding has been around ever since computers have been around. And there's various reasons why. One is that this style originally 20 years ago was easier for compilers to actually generate better code for. It generated smaller code. Machines didn't have as much memory. They didn't have as much horsepower, etc. So it was for machine reasons. The second reason was that for a coding style, what tended to happen is people wrote very large main programs and nothing else. And so inside a single bunch of code that was really, really long, you would have to have these if statements to basically say, I'm only gonna do this situation if this is correct, and put the stuff, the good stuff, inside the if statement, okay? But the problem is, times have changed in the past 30 years. Compilers are smarter, there's more memory. It doesn't matter if it generates a little extra code, although the compiler will take care of it. We tend to write smaller functions than we used to write, and so they're generally very sorts of small things like this. And so this style, even though you see it over and over and over again, is just going to cause you untold grief. Every time somebody comes along and says there's another reason that we have to be careful of, this line gets longer and longer and longer on the right and more difficult to understand every time there's some extra reason, like a calendar description, right? If you read some of them about prerequisites. So let's do what we did for the second alternative, and let's split this thing up a little bit differently. And so I'm going to get rid of this, and I'm going to actually take it back to what we had originally. I'm going to leave that there, and I'm going to go in and I'm going to write the other style of if statements, which is to say if more money is smaller than 0, then just get out. Okay? And I'm going to write the other one as a separate if statement. If more money is greater than the 500, then get out. Okay? And there's a couple of things here that happen. The first one is that notice in this style, I didn't move this line of code at all. right? What I did was I wrote the standard, important, ordinary thing that normally works. I left it sitting all out by itself where people could see it. And when there was a problem that I wanted to take care of, I made reasons to not do the thing before I got to that line. Okay? So the good stuff isn't buried inside the if statement anymore, looking like it's something that doesn't get very often. It's getting done very often. It's sitting out there all by itself in a place where people can see it. And anytime somebody says, oh, but, or if this happens, you can't do this, then life becomes really easy. Every time they give me a yes, but, I just turn around and add their reason in as a separate if statement.
So the return function, what does it return to exactly?
It goes back to whoever called it. So it's just it's not listening. So it goes right back to the main program.
Okay.
So
it won't go back into that function again?
No,
Okay.
no, it's done. It's just a quick exit.
Right.
So return early rather than going through. And so now, after you get this little pattern where when you're writing code, the best thing you can do for yourself is put on the rose-colored glasses, and no matter what people say about all the problems that could possibly happen and all the things that could go wrong, you just go, oh, well, if life were good, this is just the normal thing that would work. And after you get that to work, then you go back and you start worrying about what are all the bad things that can happen, and you just fit those in up at the top as rejections. And it becomes really, really easy to write the code. And usually what happens with students is if I give an assignment where it says you can't do this and you can't do that and you can't do that, then people get all twisted up in that other form trying to write an if statement that solves all of their problems at once, rather than just going, oh, what's the normal thing I have to do? Okay? And so throughout the class, I'm going to do this style consistently, and I'm going to never use an and or an or believe it or not, an else. Ever. And we're going to do some surprisingly complicated things just by using this style. Okay? People will do other things in other classes. They're welcome to do that style of coding. But for this class, this is the style you're going to write.
So what would the difference be between doing it like that and, say, just nesting the if statements?
There's no nesting. And here's one of the other good points about this thing. It's a debugging skill. Because what happens here is when we run this thing with the debugger and try to see what's going on here, and we'll eventually get to this is going to run multiple tests, but it doesn't really matter. I'll find one eventually. Let's say yes to this. So here we are in the debugger, and there we are at this if statement. Okay? So watch what happens now. If more money, ignoring the fact that we know what it is, let's just suppose that we're trying to see what's going on here. If we do a step over, it drops right past that. And so it's like, oh, okay, that's not a problem. Drops right past that one, that's not a problem. Okay? So the if statements just basically get ignored. I'm not reading extra code. I'm just looking at what's going on. Okay, we'll try it with another one here. There's going to be a different test coming up here. That's another test where more money is 100. So we'll just run past that one with resume. Here's a breakpoint with 200. That's another instance of the thing. There's a 100. I'm just looking to see if I can get it. There's a negative number. Okay, so that was the test that's doing is there too little being sent in. So now what happens when I do a step over is all of a sudden it goes, oops, I'm done. Okay? If you'd written one if statement that said and this and not that and blah, 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 and you did a step over in the debugger, you wouldn't know which of the three wrong things was the thing that didn't allow it inside the if statement. In this case, I know exactly the reason for rejection. Right? Which is exactly what the student knows at the front door. There's no doubt about why they're not being let into the class. Okay? Now, the other thing that you'll discover with this style is that when you're reading other people's code who do this style, you don't have to read any of the if statements. because all of the good stuff about what normally happens is down at the bottom. And so you literally throw away the if statements from view. If you do it the other way around and you code those ones that are trying to protect against and only allow in if that's true, then what happens when you see a piece of code like that is you have to read inside every single if statement, because that's the stuff that contains the goodness. Okay? And so you have to start going through and reading every line of code that's in the thing. And in this game, you find that you can throw away whole pieces of code and not have to look at them, except in the case where you've got a problem where something's not working. Okay? So it's a much better style for this sort of modern object-oriented way where the functions that we're writing are very, very short. Kick out all the badness at the start and then just leave the good stuff. And we actually write these in reverse. I always say write the good stuff first. Don't worry about the special cases. Go back and add them later. Okay? And we'll spend a lot of time trying to make sure we get that right and sticking to that style. Okay? Anything else you want to know about unit tests? Okay, let's close this one up and start a new idea.
What were you doing, like,